Hello and welcome to the Optimizing Infrastructure at Scale with OpenNebula's AI-powered DRS screencast. In this screencast, we are going to introduce the OpenNebula's new distributed resource scheduler functionality along with the benefits of AI-powered DRS. What is DRS? DRS stands for the Distributed Resource Scheduling that enables cluster load balancing to distribute workloads across the cluster and improve performance. Migration recommendations, allowing administrators to approve the migration plan in either automated or manual fashion. Use the resource usage forecast to enable the proactive migration recommendations. Initial virtual machine placement to place the workload on a best suited host from the get-go. Leverage the various automation options from manual to fully automated implementation of the suggestions. Improves the policy configuration. How DRS can benefit from the AI-driven resource usage forecast. Identify the potential constraints and bottlenecks beforehand. The infrastructural decisions are data-driven instead of a guess game. The workloads are getting scheduled more precisely. Supports short-term decisions for quick adjustments as well as long-term capacity planning. The virtual machines are deployed using the packing policy. When deploying using packing policy, OpenNebula is going to minimize the number of hosts in use by placing virtual machines closer to each other. Then DRS is going to trigger the workload optimization using the balance policy. Manually execute the plan to spread the virtual machines across the available hosts. Trigger the auto execution of a plan to migrate two workloads. Let me introduce you to the setup. Currently, we are running a cluster of 4 hosts. We have 8 virtual machines deployed and all of the virtual machines are occupying the same host. This is the result of a pack policy. Migration is controlled by a policy that can be configured from the cluster screen. Press Update Configuration to access the tuning screen. We have 4 options here. Let's go one by one. Migration threshold is responsible for defining the number of virtual machines that can be migrated. The predictive slider makes the DRS take into the account the forecast. The more the percentage of the forecast is set, the more the decision making is going to be based on the forecast. Under the policy drop-down list, you can pick either balance or pack. Balance is going to spread the virtual machines across the environment, while pack is going to deploy virtual machines to maximize the host usage. Automation settings allows you to go from fully automated mode, where an administrator is not being asked to validate the plan, to partial automation when migration recommendations are generated but not implemented yet, to fully manual mode when you must request the plan generation and trigger the implementation manually. In the scope of this demonstration, we are going to go from pack policy that currently utilizes the whole host to balance policy to free up the host and use all of our other hosts as evenly as possible considering their capacity. The optimization is set to fully manual, so we are going to request the optimization plan manually. Going into the balance opens up the set of sliders you can independently adjust so one DRS can take a decision based on the various components: CPU, memory, network, or disk. For this demonstration, we are going to take the CPU metric into consideration. As seen in the plan, the virtual machines are going to be evenly distributed across the host. To kick off the implementation, we just need to press the Apply button. As you can see on the screen, virtual machines are now running on the different hosts. Due to all of our hosts having the same capacity, we have our virtual machines evenly distributed across the environment. Now let's try to run optimization, but with a different configuration this time. Let's change the policy from balance to pack. The migration threshold from unlimited to 2. This time also let's do it in a fully automated fashion. After the few moments, the plan has been built and execution has been started. Since we had a limit of 2 virtual machines configured, only 2 are being affected this time. Let's close the demonstration with a short conversation on how forecasting impacts the DRS decision-making process. Right now, all of our decisions are based on current historical values. If we move the slider forward and set the predictive value to 29%, then to make a decision, DRS is going to consider 71% of the current values and 29% of the forecasted values. By navigating to the specific host onto the graph section, we can see the current metrics along with the forecasted values. Now let's conduct a DRS test under a heavy load. We are going to build a plan and will apply the plan afterwards. We have an environment with 1000 hosts running multiple thousands of virtual machines at the same time. In our environment, the load isn't evenly distributed across, and some of the host resources are maxed out while some of the hosts are empty. Let's enable the OneDRS policy for this environment. The following settings are going to be applied. Policy will be set to balance instead of pack. The automation is going to be set to manual. That means all of our actions must be validated and initiated by administrator. The plan was prepared and is ready to be applied. In this plan, you can see a lot of migrations that needs to be carried out by the OneDRS. Now let's apply the plan. As this is a rather complex scenario, it's going to take time to complete all the migrations. The migration plan was carried out successfully, and all of the virtual machines were distributed across the environment, achieving more balanced usage of the resources. This screencast is produced in the scope of ONEnextGen project. Thank you for watching and see you in the next screencast.